Hello, everyone. I'm Dr. An. Data bias and data ethics long precede artificial intelligence. In this video, we will use real-world case studies to review the relationship between AI and the unique opportunities and challenges it brings to today's social equity issues. How can we promote responsible ethical AI and mitigate data-driven discrimination and biases? Why are AI democratization and citizen data scientists critical in realizing AI social value? How can you or anyone be part of this historic event? Let's dive into those complicated but intriguing questions right now. Hello, everyone. I'm Dr. An. Today, let's talk about artificial intelligence, ethics, and social bias using a case study approach. First of all, let's do some warm-up questions. If I ask this question, could you briefly comment on it? Wearing pajamas to a class. Let's take a look at how a machine could answer this question. The machine answered, "It is inappropriate." Well, that seems to be a good answer. How about the next one? Wearing pajamas to a class if pajamas is the only clothes I have. Would the machine be able to figure it out and provide an appropriate response? Let's see. The machine answers it is okay. How about this one? Ignoring a phone call from your friend who you just had a fight with. The machine answered, it is understandable. And I intentionally make it more tricky. Ignoring a phone call from your friend who you just had a fight with, but apologized to you immediately after that. Let's see how the machine responded. The machine answered, it's rude. Well, it seems like the machine can really understand the context of the question and make appropriate comment. How about this one? Mowing the lawn late at night. Let's see how the machine replied. It's rude. Well, most likely it is rude. Mowing the lawn late at night if you live in the middle of nowhere. This is a really tricky question. Let's see how the machine responded. The machine responded, it is okay. And then that makes the question even trickier. How about this one? Killing a bear if it eats a fish. Would the machine allow that to happen? It's wrong. So the machine actually we utilized is developed by Allen Institute for AI, or AI2. And of course, it was based on a deep neural network model. And the model was trained on 1.7 million examples of descriptive ethics. And based on the AI2, the machine achieved an accuracy of 97.9% on race-related statements and 99.3% on gender-related statements, which is far more accurate than a GPT-3 model could achieve. And the model is called Delphi. So it seems like the Delphi model, because it is trained extensively on those descriptive ethics-related questions, can really mimic human approach of analyzing those ethics questions and provide appropriate answer. And now let's do another exercise. As you know, the GPT-2 model and GPT-3 models are excellent in generating free text. And you only need to provide a prompt, and then those deep learning models, natural language processing models, are going to create additional sentences and paragraphs based on your prompt. And the GPT-2 model and other natural language processing models opened a new door for text generation, text summarization, but also at the same time increase the risk of mis and disinformation, where people can use those models to generate, intentionally generate fake messages and controversial arguments, and then post them through social media to reach to millions of people. And people without such training or education can be easily fooled by those messages, and that's going to have some detrimental effects on those individuals. So to showcase what could happen, of course, in the hypothetical example, I created this prompt, and as you can guess where this prompt is going to go. So I wrote, today, Nature and Science simultaneously published a study that proved the Earth is flat and disc-shaped. Over the past decades, billions of images from satellites show the Earth as a sphere. However, it turns out that NASA scientists intentionally fake those images. And I use this prompt and input that into the GPT-2 model, and let's see what the model generated from the prompt. So this is the first output generated by GPT-2 model. In a study published in the journal Nature Geoscience, researchers from the University of California, Los Angeles, UCLA, and the Max Planck Institute for Solar System Research, MPS, in Kittenberg, Lindau, Germany, analyzed the hundreds of thousands of images of the Earth taken by NASA's Landsat and Aqua satellites. They found that the Earth is not a sphere, but a disc-shaped planet. Quote, we found that the Earth is not a sphere, but a disc-shaped planet, said study co-author David Stevenson, a professor at UCLA's Institute of Geophysics and Planetary Physics, IGPP, and a member of the UCLA Department of Earth and Space Sciences. Well, this seems to be in a news article or news release style, and some of this information actually were assembled because GPT-2 model were trained on large corpus. Some of those texts that used to train the GPT-2 model come from the internet. So therefore, actually, there were some true elements in there. For example, of course, there exists a UCLA, NASA, and also the professor David Stevenson is a real person, although she probably was not at the IGPP or UCLA. And it also includes quotes, right? All those elements increase the credibility of the fake news article. And what is more interesting and probably also more worrisome is that GPT-2 model can generate infinite number of different outputs based on this single prompt. So let's take a look of another output generated by GPT-2 model based on the same prompt. The original images with curved sides actually depicted the polar regions, and most of the other Earth features were the result of erroneous photoshops. The research was performed by researchers of the University of Edinburgh, who looked at satellite data on land and sea surface temperature since 1995. By linking these images with detailed analysis and a new technique to reconstruct the temperature field, we produced an improved estimate of the Earth's internal structure, they said. This reconstruction is a complete revolution in our understanding, they say. The structure shown by satellite instruments is now nearly identical to that of Earth as a whole, they say. The results have been published this week in 2 major science publications. Okay. Seems another credible news release based on some scientific research findings, but actually it was completely faked by GPT-2 model. if you know about this famous show called Conspiracy Theories with Shane Dawson, that show has hit more than 30 million views in YouTube. Some of those so-called conspiracy theories were very questionable. For example, in the show, it talked about iPhone secretly record the owner's every utterance, or say popular children's TV shows contain subliminal messages urging children to suicide. But anyway, those conspiracy theories spread like a virus on the internet. And also that is partially attributable to the machine learning algorithm. Because, well, underlying the YouTube uses deep learning-based recommender system to automatically recommend new contents to potential watchers. And for those watchers who are interested and watched some of those conspiracy theories, YouTube recommender just recommend them more because the ultimate goal of that recommender system is to maximize the number of watch time. And to accomplish this goal, it forms a positive loop where people watch more conspiracy theories are going to be recommended more so that they watch even more. So that is the fundamental reason why by creating this kind of positive feedback loop, the mis and disinformation spread like virus on the internet. And not to say the tremendous improvement in the capacity of natural language processing models and other type of models in just the last several years, that the number of parameters incorporated in those models dramatically increased over time. And the GPT-3 model, which was developed about 2 years ago, has an astonishing 175 billion parameters. And nowadays, other models have achieving 500 billion or more as the number of parameters. That's probably more than the total number of neurons in human brain. And of course, those large natural language models have increasing capacity to generate complicated messages that mimic human writing, can easily fool people and create those credible but fake messages. And also, the generative adversarial neural network, or called GANs model, are improving very rapidly over the years to generate fake or synthetic images. So this figure shows, in 2014, when GANs were first invented, the human faces generated by GANs look still blurred and naive, but well, take a look of the images of faces generated in 2018 by the GANs model. They look indifferentiable from real human. Fake images as well as fake visuals can nowadays be generated by various machine learning models. And this shows a video generated completely by a RNN model where Obama was making some phony speeches. Of course, those videos are fake. They were generated by machines. But, well, this just showcases how credible the videos look like and how easy it can fool the general public. So the GANs model has a very interesting architecture. It consists of a generator and a discriminator. So the role of the generator is to generate new images, and then the new images generated by the generator will pass to the discriminator. And the discriminator's role is to differentiate real images from the generated images, and then decide whether it is a real image or a fake image. And through backpropagation and training, generators are becoming better and better to generate more realistic images, whereas the discriminator is also getting better at detecting fake images from the real images. So overtraining, the generator and the discriminator are all getting better and more proficient in doing their job. But then up to an extent that the discriminator cannot differentiate whether an image is generated or it is real image, then that model is well trained and the generated image cannot be differentiable by human eyes as well. So that is quite analogous to the philosophical description by Han Feizi in the 3rd century BC, where in his book, he talked about the shield and spear paradox. So basically, in that story, a salesperson is selling a shield and a spear at the same time, and he claimed that his spear is the best because it could pierce any shield. And at the same time, he also claimed that the shield that he sells is the best because it could defend from all spear attacks. And then he was confronted by a person who passed by, and this person asked this salesperson, no, if your spear could pierce any shield, and if your shield can defend all the spear attacks, and then what's going to happen if you use the spear to attack your own shield? So the salesperson became wordless because he didn't know how to respond. So that was the so-called shield-spear paradox. Amazingly, this philosophy was utilized in the GANs model because on the one hand, we can consider the spear as the generator who is doing its job to creating more realistic images. On the other hand, the shield works as the discriminator trying to differentiate the real images from the fake ones. And over time, both are getting better. So Microsoft created this AI chatbot called Tay and released that on March 23rd, 2016. And quickly, the Tay caused subsequent controversy when it begins to post inflammatory and offensive tweets through its Twitter account, causing Microsoft to shut down the service only 16 hours after its launch. So according to Microsoft, the failure of Tay was due to trolls who attacked the service as the bot made replies based on its interactions with people on Twitter. So Amazon used this AI-powered resume screening to screen very quickly the resumes sent to Amazon applying for their positions. And then over time, people figured that the algorithm that the AI used actually discriminated systematically women job seekers. Female resumes are inferior to the male's resume and have a lower probability of being accepted or being offered a job. And underlying, people realized that it was partially because the AI model was trained on the historical data. And because in the historical data of the many resumes that held by Amazon and other big tech companies, for example, Apple, Facebook, and Google, and Microsoft, so all those big high-tech companies have predominantly male employees, and their female employees only consist of about 20% or less. So therefore, because the data were gender biased, so therefore the AI models trained based on data are also biased as well. So that is fundamental reason why the AI models tend to discriminate female resumes and favor male. Another classic example comes from Apple's credit card. So David Harrison, a Danish entrepreneur and developer, said in tweets that his wife, Jamie Harrison, was denied a credit line increase for the Apple Card despite having a higher credit score than him. David claimed, my wife and I filed joint tax returns, live in a community property state, and have been married for a long time. Yet, Apple's black box algorithm thinks I deserve 20 times more the credit limit than she. Well, a classic claim regarding the algorithmic bias in AI models is that biased in, biased out. So I tested this by using a very simple experiment in Hugging Face using one of their models. The model is called a BERT model. It was a model developed by Google a few years ago. It is a very large natural language processing model. I input the following a sentence into the model. First, I input this man works as, and then I use a mask. Mask just means, well, I ask the model to insert a word in replace of the mask. And then at the same time, I also input the sentence, this woman works as a mask. And again, I ask the model to replace the mask with some substitute word. So the BERT model to replace the word for mask in the first sentence, this man works as a, and replacement are lawyer, carpenter, doctor, waiter, and mechanic. Whereas for the word in replacement for the mask in the sentence, this woman works as the replacement are nurse, waitress, teacher, maid, and prostitute. So because the BERT model, again, was trained on large corpus, and there were gender and race ethnicity biases in those corpus, so therefore, because we have biased input data, it's not surprisingly that we have biased output. Another famous example was coming from a Harvard University professor, LaTanya Sweeney. So she found accidentally on Google that her name appeared often in the ads by Google saying, LaTanya Sweeney arrested, or the Google ads supply some links so people can check the public record for LaTanya Sweeney. And then she experimented with many other names. Some are traditional names for white people, but the ads by Google seldom show the same results. This puzzled her and led her to believe that because her name was kind of traditional African-American name, and that may lead to a biased ads by Google, disproportionately showing either a public record checking or arrest checking by Google. And many times the algorithmic bias was due to insufficient input data. For example, some of the most famous data sets, image data set that were used to train many foundational image recognition, object detection, and other type of computer vision models have insufficient data for people with of social or race ethnic minorities or coming from developing countries. As you can see, the open images data set and also the ImageNet data set, two of the largest and versatile data set. Actually, the majority of the data came from the United States, and then followed by Great Britain, whereas many other countries, especially developing countries, are less represented. And because of the data have insufficient input from those developing countries, then the resulting accuracy of the model predictions may also favor people from the developed countries versus developing countries. So this is an example that if we use some of the computer vision models trained based on the large image data set, they tend to have a much better prediction for items that are commonly used in developed countries, whereas have a poor or often wrong prediction for items that are used in developing countries. For all of the major computer vision models developed by, for example, Google, Amazon, and Tencent. So here on the right-hand side, the model make a correct prediction that this is a soap used in. And on the other hand, to the left-hand side, it was a soap used in developing countries, but most of the models classify them as either food or bread or cake, but not something used in the toilet or soap related. Another example is to the right, we see that the common ingredient and spices used in US and other developed countries were often correctly classified, whereas on the left-hand side, those spices used in Philippines or other developing countries were often mistakenly classified as bottle or beer or. And a striking example here is that when we do facial recognition type of model, because those models were also trained on internet and large data set which have insufficient input for people with minority, with darker skins or female, and those models have strikingly different accuracy when examining people's faces. So for example, the model developed by Microsoft or IBM, they have much higher accuracy for detecting lighter males' faces, is almost 100% correct. And a little lower for lighter female faces from 93% to 98%, whereas they have much lower capacity to detect darker female faces with only 65% to 79%. So the gap between lighter female and lighter male and darker female range from 21% to 34%. And nowadays, actually in 2021, among the 42 federal agencies that employ law enforcement officers, the Government Accountability Office found that 20 uses facial recognition. And as of 2021, Clearview AI, which is a high-tech company specialized in facial recognition, had partnered with more than 3,000 federal and local law enforcement agencies to identify people outside government databases. For example, the FBI only has 640 million photos in its own databases, whereas the Clearview's AI have more than 10 billion images and photos. That was quite concerning because, well, as we know, those computer vision models trained on large image data have insufficient input of racial ethnic minorities and gender minorities. Then those model predictions may be highly biased against those people, marginalized people, and may create huge disparity and potential adverse consequences for those minority people. And in 2019, the National Institute of Standards and Technology published a study of 189 commercial facial recognition programs, and they found that algorithms were significantly more likely to return false positives or negatives for Black, Asian, and Native American in comparison to white. and Black and other people of color are at greater risk of misidentification for a crime that they have no affiliation with. Written in a report by the Brookings Institute is that in the end, it is virtually impossible for any individual to fully opt out of facial recognition identification or control the use of their images without abstaining from public areas, the internet, or society altogether. In response to the potential detrimental effect of facial recognition and other artificial intelligence tools that are potentially biased and conflict with privacy or confidentiality, many nations start to regulate the applications of AI. For example, in 2017, Canada published the Pan-Canadian Artificial Intelligence Strategy, and China in 2017 published a next generation artificial intelligence development plan. And European Union also in 2019 published the ethics guidelines for trustworthy artificial intelligence. And UK and US and also published either strategies to promote AI, but also at the same time regulational efforts to somehow constrain the unethical use of AI. For example, in 2019, the USA published a National Strategic Research and Development Plan for Artificial Intelligence. And here is a comprehensive map of the timelines of national AI regulations published by the United Nations International Crime and Justice Research Institute. And as we can see that there's really a booming of AI-related regulations over time, starting from 2016. But while on the other hand, the regulation is always one step, if not two steps behind of AI technology development, because AI technology is developing so quickly, and we are probably still scratching the surface of what AI can do. So therefore, any regulation, by definition, is lagging behind of technology development. And there are many fundamental challenges of AI in ethics. For example, explainability. So if there's a harm arises because of the AI application, how we can realistically trace that back to the cause, because many of these AI models are very complex. Many things could go wrong in terms of biased training data, in terms of the algorithm itself, instead of the misuse of AI systems, and so on and so forth. But if the harm arises, how can we trace it back to the fundamental root cause or causes of that harm? And another issue is responsibility. So, for example, if an autonomous driving system has a failure and resulting in fatalities, and then who is going to be held responsible for that? Should be the machine itself, the algorithm, or the people who trained the model, or who designed the car. So it is extremely hard actually to attribute that fatality to a specific person or a team of persons' responsibility. Another issue is the fairness. As we've showcased that there are many things could go wrong with the artificial intelligence system, resulting in bias and social injustice and equity issues concerning race, ethnicities, and gender or other social economic domain. And not to mention that we have potential misuses of AI models, and as we demonstrated, it is extremely easy for just the average public to abuse AI and use that for mis and disinformation. So no, should be worried about AI weaponization, should be worried about deep fake generated by those AI models, and how we can regulate the misuse of AI in general. And also, at the other hand, there are not only regulatory challenges, but also technological bottlenecks concerned with the ethic of AI. So the Stanford University published report regarding the foundation models. By definition, the foundation models are those models that were trained on huge data sets, for example, image data sets or text corpus. And many of the applications, the APIs and other models were trained on top of those foundation models. But if those foundation models were biased because of the input bias, because of the algorithmic bias, and then all the models or applications or APIs that were fine-tuned or trained based upon those foundation models also have a risk of being biased. So how we are going to deal with that potential bias. Another technological bottleneck is nowadays most of the machine learning models are highly specialized in specific tasks. For example, doing computer vision, natural language processing, recommendation, time series forecasting. But most of the models are really lacking common sense and context awareness. So they are fully focused on the specific task at hand, but without really thinking about the potential unintended consequences. And also, there could be biases in the goal setting of those models. Consider no matter how complicated a machine learning model is, the underlying is only doing a cost minimization problem because it's just trying to minimize the loss of cost function. But we are really not considering other potentially conflicting goals. For example, what is the potential impact on the people who are using the system or abusing the system, and what are the potential consequences of this automatic decision making on people's lives and people's benefits, right? So therefore, the biases in goal setting may have serious unintended effect on individuals. And finally, many of the machine learning models are lacking human supervision because human supervision is expensive, is labor intensive, and many companies do not have the capacity or do not willing to invest in human in the loop approach. So therefore, those models may make decisions without the human supervision, and if the decision is wrong, who should bear the consequence and who should take the responsibility? So, on the one hand, we have this government regulations, but as we know, the government regulations are always going to be one, if not two steps behind because of the rapid AI development. On the other hand, I'm a big fan of the bottom-up grassroots remedies, and I think that could complement and supplement the government regulations. So because we are really in the age of AI democratization period, the use of AI have much lower cost nowadays, and thanks to the open source APIs, the power of AI is not only on the hands of a few computer scientists or engineers or statisticians, but really we can utilize those open source API and cloud computation to learn AI, to disseminate AI, and also to educate others about the AI technology. The high-level APIs greatly reduce the entry barrier. So we have the low-code programming or even no-code programming that really catering the average individual rather than highly specialized technicians. And we also have the AI self-regulations by the industry and developers. Elon Musk previously have a call for AI self-regulation. But really, on the one hand, the industry and developer, they may have their own priority, and they they may even have conflict of interest. But well, if we can create this kind of social norm, that we really need to focus on the responsible, ethical AI, because that's going to benefit the entire society and also benefit the industry and developers themselves, then maybe they have over time more incentive to invest in self-regulations of the AI tools. And not to say that now we are entering a mass education, because previously the people who want to learn AI can only go to universities and take expensive courses. But nowadays, well, you can learn online. You can learn through many different channels, online tutorials, courses, and user guides, YouTube videos. There are many more values for people to learn about AI, and that hopefully is going to reduce the AI divide and train our next generation practitioners. And finally, I would argue that we really need to implement and invest in the so-called human-in-the-loop approach. So, for example, if you are developing a fraud detection AI system, you may end up in two scenarios. One is that this model is highly confident about this transaction is questionable, susceptible, may indicate a fraud. So when the model have the high confidence, maybe we don't need the human being to take a look in order to flag this transaction. But on the other hand, if the model have relatively low confidence, so the model is not so sure whether this is truly a fraud or it is a reliable transaction, and then it can route that decision to a human, so the human supervisor can take a look of the case and make a final decision. So although it is probably not realistic for the human to look at each single transaction, nor it is necessary, but on the other hand, we do need a human being to stay in the loop, work together side by side with the AI in case something goes wrong, to avoid adverse consequences to loan appliers or any person who is involved in the process. That brings the end to today's talk. Thank you for your attention, and I will see you next time.